The day after receiving his Nobel Prize, Victor Petrik received the US patent number US 7842271B2 for the method of the industrial production of graphenes with priority starting from 2004.
Так можно представить себе.
This is how you can imagine the graphite particle.
Она точно напоминает вот этот пакет.
It is exactly like these sheets of paper. Each of these pages is a two-dimensional carbon crystal received in 1996 by the recommendation of IUPAC and given the name graphene.
По рекомендации ИУПАК название графен. Как произвести?
How does the composition of graphite come about?
Мы сейчас
We will create right here the so-called graphene.
прямо здесь так называемые графены. Я продемонстрирую.
I will demonstrate the cold destruction of graphite, resulting in the graphite crystallite being broken down not only into separate graphenes, but also into the graphite blocks containing 2, 3 or more graphenes.
Содержащие 2, 3 и более графенов. Сейчас я покажу.
Now I will show different ways of how it looks. I will show it by the table. We will also show a few fragments of industrial production, where you can run a ton of this product and after, say, 20 minutes, get a huge amount of product, which I call highly reactive carbon mix.
Огромную гору продукта, который я назвал углеродная смесь высокой реакционной способности.
Why is it called highly reactive, and what are we going to see? We will see the following phenomenon. A single graphene will be deformed, and next to it, the following graphene follows suit. It turns out, look at that, it turns out that a chromogenic carbon mass, consisting of graphite graphenes and packages, we will now see.
Мы с вами сейчас это увидим.
This is a porcelain object, apparently used in bathrooms.
Видимо, для каких-то ванн. Он удобен.
It's convenient, thanks to a dent here, to demonstrate what I'm talking about.
О чем я сейчас рассказываю. Для того, чтобы показать
to show the method of the cold destruction of graphite and the receiving of graphenes, I need a special chemical compound which will start a chain reaction. I need a graphene which has already entered the interlayers of space, the chemical compound. And I need a special initiator which I will show subsequently. How to launch a reaction in an intensive way, where for a few seconds there is literally an explosive eruption. Now I'm wetting our porcelain object. Showing that there are no acids. You can touch it with your hands. This is completely harmless in terms of activity regarding, in this case, your skin. I need some time so that the film here will be almost dry. Then we pour a little bit of our graphite, which was prepared by me in a way that I've already explained. In this case, I take a little bit of our graphite.
Наберу немножко нашего графита.
And pour it on the surface.
Надеюсь, слышите.
I hope that you can hear that distinctive sound.
Мы видим, как, видимо, маленький
We see how, apparently, the small one explodes, and we see this chain sequence.
взрывается, и видим эту цепную последовательность. Я выберу несколько таких
I will try some of these larger pellets in order to show the particularities separately, how this chain reaction goes, how it can launch the process.
Идет эта цепная реакция, как она может запустить процесс, как, ну так, чтобы ваша камера больше лучше видела.
In order for your camera to see, in order to launch a large fragment,
один большой фрагмент. Вот мне кажется, что
it seems to me that we have clearly seen how. Here's one more that's left.
Остался. Вот она.
Here it is, the beauty and the triumph of science and high level of invention.
И высокого изобретательства. Вот некоторые даже упав там.
Even some of them that fell are processing.
Между тем, как отрывать графен.
Meanwhile, how to separate a graphene by using tape in this phenomenon, an abyss. More than 10 years have passed, and still no one has been able to repeat this experiment. Digital photography of graphenes produced using cold technology developed by Victor Petrik. Photographs were taken at the University of Irvine, California by Professor Zhang Guojiang.